In this question, we're told that an underground train accelerates uniformly from rest at station A to a velocity of 24. It maintains this speed for 84 seconds until it decelerates uniformly to rest at station B. The total journey time is 116 seconds, and the magnitudes of the acceleration and deceleration are equal. Okay, so there's a lot of information there. I'm going to want to represent that in a diagram. So let's just set up our axes. We have the vertical axis being the velocity, horizontal being time. So initially, the train accelerates from rest to a velocity of 24. So from 0 to 24. I don't know the time period for this, but I'm just going to leave that blank for now. It then maintains this speed for 84 seconds. So I do know this time interval of constant velocity. And then it decelerates uniformly until it gets to station B. I'm told that the entire time is 116 seconds, and the magnitude of the acceleration and deceleration are the same. So that means the time it takes to go from 0 to 24 is the same as the time it would take to go from 24 to 0. They have the same magnitude of velocity change, so they're going to have the same magnitude of time. Both of these I'm going to refer to as t. So these two intervals are t. Part A of the question says, find the time it takes the train to accelerate from rest to 24. Well, that time is t. I've labeled that as t. So the question really wants me to find t. Since we know that the total time of the journey is 116 seconds, there's quite a straightforward equation here. T plus 84 plus t equals 116. 2t equals 32. T equals 16. It took 16 seconds to accelerate from rest to 24 meters per second. It also took 16 seconds to decelerate from 24 meters per second down to rest. Part B of the question asks us to illustrate this information on a velocity time graph. Well, I already did that. That helped to see what was going on in the question in the first place. So whether I was asked to or not, I knew it was a good idea to have a velocity time graph to show exactly what was happening here. So those 2 marks I've instantly got. Part C asks us to, using the graph or otherwise, find the distance between the 2 stations. I'm going to use the graph. I know that on a velocity time graph, the distance is going to be represented by the area. So the shape of this velocity time graph is a trapezium, and I'm just going to use the formula for the area of a trapezium. So half of the top length is going to be 84, and the bottom length is the full time of the journey, 116, multiplied by the height. And the perpendicular height here, in this case, is 24. All right, so now we've got 12 times 200. I can do this all in my head, no need for a calculator. That gets us a distance of 2,400 meters. The distance in between station A and station B is 2,400 meters.